Hello, this is Todd Horton, and welcome to this video on data collector operations using Spectra Precision Survey Pro software. In this tutorial, we're going to walk through the manual entry of a set of conventional traverse notes. This is a good way to learn the mechanics of Survey Pro, even when it is not connected to an instrument such as a total station or a GPS rover. So we will walk through this whole thing, entering the data and doing a complete traverse adjustment. Let me help you understand what was going on in these notes. First of all, we have a five-sided traverse. There are 5 traverse stations: point 11, point 12, point 13, point 14, and point 15. And from those 5 traverse stations, we collected side shot information on the points that you see labeled 31, 32, 33, through 34, 35, 36, and 37, and 38. There was also possible encroachment problem of a shed on this site that crossed the boundary line from an adjoining property. So we will walk through this data. This is just the first page, and you can see we've on the second page shown some information on the shed that we measured, and at the end we have a check, a closure check. We found out that in this traverse we only had 3 seconds of error, which was acceptable on an angular basis. So we're going to plug this into Survey Pro and see how it works. Okay, so let's jump right in. We're using version 6.1.1, and you can download this for free from the Trimble website, and you can run it in demonstration mode, which is what we're going to do. The great thing about demonstration mode, it allows you to store up to 25 points. It doesn't make all the modules available, but it's everything we need for learning the basics. So I'm in demo mode, and I'm going to start a new file, and I'm just going to name it with my name, and similar to what we have in some courses, I'm putting the problem set number behind that. I want to make sure that I have the correct settings in place for this project. So when I click on the settings, I can verify that I have a north azimuth. My grid direction is northing and easting. I'm working in US survey feet, and my angular units are degrees. I'm not going to worry about a curvature and refraction coefficient for this particular survey, so I'll press next. A control file is something we can use when we are using a predetermined or previously determined coordinate system for a site. We're not going to do that here today. We are going to assume a coordinate and a direction. A coordinate system would be something we could select, such as a state plane coordinate system like we might see here in the United States, but that's not appropriate for this particular project. So we're going to leave select coordinate system turned off. But what I will do is start with a first point. We don't always have to do this. You can see I can turn that off, and if it's off, the job will be created with no initial point. But in this case, let's go ahead and do that. And for this particular survey, our first traverse point that you recall here, this first traverse point was point 11. That's where we started our project. And in the field, we don't have to assume a coordinate or a direction. But here, we will in order to make the computation. So I am assuming a coordinate with something I like. For convenience, I'm just going to use 10,000, 5,000. That way, my values of northing and easting are different enough I can tell them apart. And I'm using an assumed elevation. My first description that I store with this point just is TRAV, or I'm just going to make it TR, which will be consistent with some of the other things that you'll see very soon. So when I do this, I say finish. I have now set up a project. Your software may default to this. This is a customizable home screen, so that when you click on the little home button, you see this. But we're going to work from the main screen, or the main menu screen, and that is the button up here in the left. So when I click on that, it takes me back to the main menu. Let me help you understand a few basic things. Over here I have a map view, and when I click on the map I can see point 11. When I click on point 11, I can see that it has this northing, easting, and elevation that I just assigned to it. It says that it was a grid key in point that you can see here. Tells me that it's keyed in. If I need to, I can add some notes. Okay, I'm going to green X back out of that. And if I green X out of this, it takes me back to my main menu. If you want to see a listing of the point, well, if I go into jobs and then hit my points button here, you can see another listing. It shows just the one point, and when I double click on that, once again I can see the same data I saw just a moment ago. So I'm going to return to the main menu, and now I am ready to start entering data using the survey tool. So from the main menu, I'm going to go to the survey tool. Well, the first thing that happened in my field notes that you see here is I said where the instrument is sitting and where it was backsighting. So you can see the instrument's sitting here at 11, and my backsight is at point 15. I set 0 on that. And you can also see that I was working in sets of direct and reverse. Well, to make this simple, what I've done is calculated the average angle for each of the things we've measured, and that's what we'll enter in our data collector in Survey Pro. You can also see distances here. This is the distance measured from point 11 to point 15. I'm going to do a station setup here, and I have a couple of options for how I set up. If I pull down the black arrow next to known point, you can see there are 3 setup possibilities: known point, unknown point resection, and multiple backsights. Well, in this case, we are going to use a known point because we have established a coordinate for point 11. It's the only point in the job right now, so it pops up on the list. We did not measure elevations, so I'm going to turn this to a 2D survey, and thus I'm going to ignore elevations. Down here at the lower left, you can see it says we have no current setup. So to proceed, I'll say next. The listing up here under Backsight Azimuth gives us 3 options. One is we can observe and store a new reference point for the orientation. We can use an existing job point for a reference, and we can orient along some Backsight Azimuth. Well, in this case, point 15 does not already occur in our job file. Therefore, it's not an existing backsight point. We can create a new point, though, and this will allow us to establish a direction from our occupied point to our known point. And for simplicity today, I'm going to assume the direction from point 11 to point 15 is north. It's roughly north in the grand scheme of things, and to get us started, this is close enough. So the backsight azimuth would be 0 degrees, 0 minutes, and 0 seconds. Now here's just a note of clarification. When you see in Survey Pro an entry like this, the point here represents a whole degree. The first two places to the right of the decimal represent minutes of arc, and the third and fourth places represent seconds of arc. So when you enter data like this for an angle in Survey Pro, it will interpret it this way. So we're going to assume that direction. For target, we have roving target and fixed target. Most of the time you're going to be using roving target, and fixed target is when we have a backsight prism set up on a tripod and it's not moving. We are assuming at this point, since we are in manual entry mode, that our instrument is pointed toward the backsight. Well, we don't have an instrument in this case when we're running the software this way, so it assumes we're going to enter those data by hand, and that's what we're going to do right now. So if I say measure and set, the red button down here in the lower right, it comes back and says, okay, I need you to enter the data for your backsight reading. Well, what was that reading? Well, let's go ahead and look here. I have 0 degrees, I set that, and my distance is 1006.53 feet. Let's do that. 0 degrees. If I toggle here on the zenith, I'll see it's changed from zenith angle and slope distance to vertical distance and horizontal distance. Okay, so I'm going to leave my vertical distance set to 0 because I'm ignoring elevations, and I'm going to set in my horizontal distance. Now when that is good, I can green check, and it advances me to the next screen, and the point I'm going to store here is 15. Okay, and the description here is a backsight, so I can green check, and you heard the little system sound there. That's the sound that we get from Survey Pro that when something is stored. Now this tells us, hey, we're occupying point 11, we are backsighting point 15, we've assumed a direction, and we can finish now. And if I look carefully at my map view, here is my instrument occupying point 11, and here is point 15. And you can see that's at least 600 feet away based on the scale bar. Well, we'll see more of our points appearing on the map as we go. So now we're ready to jump into a traverse side shot process. So this tells me up here that I am occupying point 11, backsighting point 15, which is now stored. It has a coordinate, and the azimuth between 11 and 15 is 0 degrees, 0 minutes, 0 seconds. So let's jump in here and look at my traverse notes. You can see that the next point I'm going to set is point 31, and so I'm going to change that 31. That's my point number. And when I look at the description right down here, you can see it says iron rod found. So I'm going to use a description, and I'm going to type in IRF, which stands for iron rod found. Hit tab, and that clears the keypad. And now I'm entering this as a side shot. That is, it's not on the traverse loop, it comes off to the side of the traverse loop. So normally when I hit side shot, it would cause my instrument to make a measurement if we're connected to the instrument in the field. Since we're not, we're going to have to enter that manually. So here you can see it's asking for an angle right. My angle right, my average angle right was 160.4654. So I'm going to plug that in, 160.4654. That's 160 degrees, 46 minutes, 54 seconds. My distance was 170.82 feet. 170.82 feet. And now, when I hit green check, that's the same as hitting side shot. When we're in manual mode, I get a chance here to change my description just in case I didn't get that correct. And since it's okay, I'm going to say green check. Now let's take a look and see what happens on these tabs on the right. Here I'm in the input tab. The point number that you see down here in the white window is the point that I just stored. This point up here at the top, 32, is the next point that is available to be stored. It advances the point numbers by 1 by default. So it assumes that you're going to just keep going using an increasing sequence of numbers. Well, let's look at the result here. Result tab on the right. This shows point 31. It has calculated the northing and the easting. We're not worried about elevations. We're working in 2 dimensions only. Here is the angle right that we entered. The zenith angle was set to 0 because our horizontal or vertical distance is 0, and you can see the horizontal distance. Then, this is really cool. Look at the map. Okay, here you can see the green line is the backsight line from the instrument to the backsight point. And then as I zoom in, you can see this is the direction and the location where point 31 is stored. So every time you store a point, it shows up on the map. All right, so let's go back to our field notes and see what's next. From this first setup at 11, now we are taking one more reading, and it is to a traverse point. How do I know that? Well, if I take a look on my map down here, here's 11, here's 12. 12 is the next point listed. It is a traverse point. You can see it says traverse nail set. So I'm going to plug in this angle, 106, 24, 43. Okay, now so I'm calling this point 12. And instead of hitting side shot, I hit my down arrow here and I pull up to traverse because it's going to do something special. It gives me the option to say measure and traverse now, which is what I want to do at this point. We can traverse later or traverse from a different point, but for this type of entry, we're going to proceed with the red button. So measure and traverse now. I need to plug in that angle. We said it was 106, 24, 43. 106, 24 minutes, 43 seconds. And my horizontal distance is 644.09. 644.09. 644.09. There we go. So when I green check, you got to remember, normally your instrument provides all this information because it's connected to the data collector, but since we're working manually, we have to hit the green check. And here I can green check again, and notice what it does. It says, hey, you have now moved the instrument from point 11 to point 12. So that's your occupied point. Your backsight point is 11. And we're setting the backsight circle of the instrument to 0 degrees. That's not an azimuth. That's the reading set in the circle, the horizontal circle of the instrument on the backsight. Okay, so if I say measure and set, watch this. Now it's asking me for the information, the measurement information to my backsight. So my backsight at 11, now notice I'm sitting at 12, backsighting 11. I set 0 there. I set 0. And I shot 644.07. So let's do that. I'm going to leave my angle right to 0, and this was 644.07. Okay, if I say green check, notice what it does. It gives me a horizontal distance error that is 0.02 feet, and it calculates what component of that is the northing and what is the easting. Why is that? Well, notice right here in the notes, I can see that I had 644.07 is what I measured this time, and 644.09 from the last time. Okay, so now I can say finish, and notice it says my occupied point is now 12 and 11, and my backsight point is 11. This direction 286, 24, 43 is the computed direction from 12 to 11. Notice in my description it shows the most recent description that I have used. My foresight point at this point is not going to be 13 yet. I'm going to change that because my next foresight is going to be side shot 32. How do I know? Well, I'm looking at the notes right here. My next reading is 32. Okay, so I'm going to plug this information in. So for a little bit here, I'm going to speed things up because you don't need to listen to me talk while you watch. So watch what goes on here, and I'll slow down and show you a few things as we go when necessary. At this point, I'm getting ready to take measurements on the building corners that show up on my field notes. Here is a larger enlarged detail showing where there is a shed. It's owned by folks that are east of this line, and we believe the shed encroaches or it crosses over the boundary line onto our client's property. So we have taken measurements at point 51 and point 52 at the corners. Notice in our notes here we say we shot it using our reflectorless method instead of using a normal prism. So we're trying to determine how far across the line it will be. We can compute that later. So I'm showing a different code here, just showing it as a building, and my angle right, we had what, 283, 44, 31. And 310, 52. Okay, notice that shows up as a building. And I'll do this again. Now I need 285, 10, 53. And I need 312.06. Now, I have to be careful not to keep using the same point numbers. See, now my point number goes back to 33. So sometimes what we do is we change point numbers just to indicate that The kind of feature we're using is, or that we're mapping is different. So I'm just going to go back in here and type in IRF, and I'm going back to side shots. Okay, now here's something very important. At this point, we have traversed around our loop, and now we're occupying point 15. Let's go back to the beginning and see this. Point 15 is there. That was our first backsight. Well, here's my problem. I have one record of point 15 here. It is here. See that? It already exists. I can look at it and see that it has a coordinate. But if I say, hey, I want a foresight 15, here's my problem. When I take a new measurement to 15, it will ask me, do I really want to overwrite that? So let's just watch this. If I put 15 in and I say traverse, it says, whoa, 15 has dependent points. That is, other things depend on it. It cannot be overwritten. So we can't overwrite the existing point. We could use the next available point number, but rather than using 16, what I like to do for data management purposes, I like to put a prefix number on this. So instead of calling it 15, I'm going to call it 115. See that? So that way, both versions of this point, the original 15 and the new as measured position, will be ending in the same two digits. So let's say I go to traverse again. Now my notes say I'm at 15. My data collector now says I am foresighting point 115. So here we go. I am, let's see, I was on the third page, right? So I need to foresight point 15 here, and I had 141, 45, 13. Now, I'm sitting at 15 in my notes. I'm at 115 in my data collector, backsighting 14. You can see my backsight distance. I did set 0, and that's what I'm showing here. Setting 0. What was that distance again? 512. I measure and set. Excuse me. I have no error that time. And I finish. Now get this. It wanted to advance my number, so it thinks I want to go to 116. Well, I still have one more side shot to do on point 38 here. And then my final shot is to point 11. Now remember, point 11 is the first thing I stored at 10,000, 5,000. So if I say 11, and if I say side shot, it says I can't overwrite that. So rather than call it 16, I'm going to call it 111. Okay. So now I'm going to plug that in. Now you might say, why aren't you traversing to it, Todd? Well, at this point, I've already occupied 5 points of my traverse with a traverse station or traverse setup. So really, I'm returning to my first one, and I'm not going to be moving the instrument to point 11 or 111 as it is now. I'm just doing my closing shot. So I have there's my angle, 56, 54, 39. And my distance was 106.43, different from the original measurement. Okay, so I store that. All right, so let's look at our map. You can see what we've just done here. There was that last side shot to an iron rod, and here was our closing shot. Here's the whole thing. Okay, so we've got it plugged in, and let me show you a couple of neat little tricks here. I'm going back to the main menu. I'm going into Job, and under Job I can edit polylines. A polyline is just a multi-segment line figure, and I'm going to make this real easy. I'm going to add a polyline by saying new, and the simple way to draw the boundary here is to use the to from button, and I can tell it, let's draw from 31 to 38 with everything between it in sequence, between 31 and 38 in sequence. So it'll go from 31 to 32, 33, 34, 35, 36, 37, 8, 37, 38. And then I want it to return to point 31. So I didn't put any spaces in. I just 31-38, comma 31. And you've got some entry examples down here that I encourage you to look at on another time. So if I do this, look at that. It draws me a nice little line. It hasn't stored it yet, so I have to hit green check to make it happen. And I can store it with this description, or I can change it and call it boundary if I'd like. Well, now, there you can see boundary, and it's defined by those points. If I close by green Xing out of this, I can go back to my map view and see there it is. There is that boundary. That's kind of cool. But I haven't yet corrected my traverse. I just showed you that drawing so we can orient ourselves. So let's go through the process of adjusting the traverse. So I go back to the main menu, and I'm going to this item down here on the lower right called Adjust. And under the measurement or adjust menu, you have a traverse adjust tool. So let's click that. And the beauty of this is this button down here in the lower left called Find Traverse. This is kind of neat. First of all, we're going to do an angle adjustment on all of this, and we're going to do a compass rule adjustment on our coordinates. We're not going to adjust elevations because we didn't hold any elevations. But if I say find traverse, look what it does. It says, oh, I see what you did. You occupied point 11, 12, 13, 14, 15, and then your final shot to close the traverse was point 111. It figures that out, which is pretty neat. Okay, so I'm going to go ahead and accept that. All right. Then I'm going to say next. And let's take a look at this note. Your selection contains these critical points and will invalidate the current setup if you continue. All right. Well, yes, it says the current occupy point is 115 down here at the bottom, and then 14 is the backsight point. Once we accept this, then it will no longer believe that the instrument is occupying or orienting anywhere. So it's, as we say, it breaks the setup. That's fine for what we're trying to accomplish at this point. Now, it asks for the observed closing angle of the traverse. This is important to understand. Let's go back to the notes for a moment. Here is our traverse. We started at 11. We started at 11, went to 12, went to 13, went to 14, and our last occupation was at 15, and in the data collector we call 15 115. The way Survey Pro wants this closing angle is they want the closing angle where that find traverse loop starts and ends. So the traverse sequence that we saw just a moment ago that started at 11 and ended at 111, well, the angle we collected at 11 is the closing angle we want. Okay? But I'm going to do it wrong first to help you understand why this is. Now, in the field, what did we do? We started at 11 and our last occupation was at 15. So we would normally think of 15 being the place where we turned our closing angle. We say we closed the traverse at that point. All right, so let's look up the angle we turned at 15. When we were sitting at 15, our closing angle was 56, 54, 39. So let's plug that in. 56, 54, 39. And when I say next, it asks, are you doing a closed traverse, that is a loop that closes on itself, or are we closing to some known location? Well, in our case, it's a closed traverse. If we say next, it gives us a preview. Notice it says preview up here of the adjustment. So let's take a look and see what it says. It says our error distance was 1600ths of a foot. Gives us an error azimuth for that short little line. But then look at this. It says angular error. Can you see this right? I'll put it, well, there it is right there. It says angular error 493001. Well, that doesn't make a lot of sense because over here in our notes, we said the angular error was only 3 seconds. So this tells me when I have something spectacular like this, I've got some kind of entry blunder. Yeah, it shows this is the angle I plugged in, but that's not the angle that it wants. So let's go back. Let's say find traverse one more time, and it says I started here at 11 and ended at 111. Well, over here, that's this location on the traverse. So it wants the angle at the location where the traverse starts and ends. That's what it calls the closing angle. So let's do that. This time we're going to plug in the appropriate value, which we said here was 106.2443. 106.2443. This time, if it's working, if I did it right, I should get 3 seconds of error. And is that what we got? I scrolled down too far. Hello? There we are. Angular error, 3.00 seconds. That's what we expected. Okay, so now we know we're doing this correctly. When I say adjust, it asks, are you sure you want to adjust? And I say yes. Well, it created a backup file. That's a good thing. And let's take a look at the results. Sure enough, there was our angular error. And now our precision has improved a little bit. And now our error distance is 0. What does that really mean? Well, that means, first of all, point 11 was held fixed. It did not move. But point 12 in the compass rule adjustment, its position changed by 0.027 and 0.017 in the northing and easting respectively. The linear change there was a result of 0.032. And as a result, everything downstream of that was adjusted. Well, here's point 13. It moved by this amount. And everything attached to it got moved. Same thing here is point 14. And you can see the amount of change, the linear change for each of these is going up. If that's point 14 and that's 0.086, then the next occupied traverse point should be larger. Yeah, it sure is. It's 0.119. And then we go to 0.111. That's the same thing as 0.11. So when we're done, the two of those should match up. And the linear change was 0.0164. You see, that was the distance between 111 and 11 before the adjustment. Now the distance is 0 between those two. So let's then take a quick look. Let's go to the map, and when I zoom in down here on point 11, if I click on it, it says, hey, there are 2 points there. Okay, now notice something about this. If I scroll over, now point 111 and 11 are the same coordinate. Why? That's because we've adjusted. I'm just going to get out of this. Okay, all right, a few things that you need to know how to do. First of all, there's a wonderful tool on here called inverse. And inverse helps us to calculate a distance between points that we did not measure directly. So let's say I want to measure between 2 points, and I want to measure, let's say, I'm just going to pick something random. I'm going to go from point 31. I'm going to hit my map icon, and I'm going to measure over here to point 33. Okay. Well, I could have also chosen from the list. I can go point 31, and then I can choose from the list again, or for that matter, I could type it in. I can just say 33. And then when I say solve, look what it does. It calculates the distance of 937.38. If I look at the map, this shows you what it just calculated. Not only that, it calculates a direction. So I've got an azimuth or a bearing for the very same vector. Really handy little tool. And in land surveying, we do this all the time. This is a very important type of computation that we depend on for evaluating our work. There's another one I really like, and this one's called point to line. Now, let me help you understand what I'm interested in. Right up here in my notes, I show point 14 falling to the left of line 3637. Okay, that's the best I can tell what I've got in the field. So what I'd like to do is find out where 14 is relative to line 3637. So I'm going to go in here and I'm going to say there's line point 36, and this is the start of a line I'm referring to. 37's right up there. Okay, and if I say solve, let's look at what this tells us. First of all, let's start with the map. This shows line 3637 in blue is my reference line, and it shows point 14 is to the left of that, and this red line is perpendicular to the blue line, so it's truly an offset. So if I look at this, this says the inverse station is 3 plus 18.885, meaning that's the distance, 318.885 down the line from point 36 to where the red vector hits the blue line. Then the offset is 12.113 left. Well, that's left of the line because the line goes from 36 to 37. Now let's look what happens if I turn that around. Let's say this is 37 and then this one is 36. It's going to give me a different result. The offset's going to be the same. See that? That's the same offset, but now the station is different. Why? Because we started at the other end of the line. This is really cool. In fact, we can use this to figure out how far to the left of this line 3233 these building corners are. We can see now that, yep, those building corners are across that line. We need to find out how much. Well, how do we do that? We use the inverse point to line tool. One last thing, the presence of the polyline on that boundary gives us some nice little opportunities. If I go into from the main menu, I go into this COGO, which is surveyor slang for coordinate geometry. Go into COGO and I say I want to compute area. Well, we have an option. It says choose a boundary for the area. We could plug in point numbers, but look at this. I can say tap line, and all I have to do is tap the line. It shows up. I say solve, and look at that. I can see that it's 14.251 acres. Saves an enormous amount of time because everything behind the scenes here is in coordinate geometry. So Survey Pro is a wonderful, wonderful tool, and it is one of many different data collector softwares out there. It's the one we use for a variety of reasons, but once you understand how this one works, all the others work pretty much the same, and the difference is what they call things and where they put them. How do you access them? So I hope this has been helpful for you, and we'll see you in another video coming up soon.